Hello everyone. My name is Anudh Mishra and I am an MBA student at AIIMS Bhuvneshwar. Today I'm going to discuss the chapter Biomolecules with you. Okay, so this is not the biology biomolecule but chemistry biomolecule. And it is a bit more elaborate than the biomolecule chapter which you read in biology if you are reading biology NCERT. Anyways, this comes under organic chemistry and of class 12th, and it covers the four basic biomolecules found in living organisms, which are carbohydrate, fats, or lipids, then your proteins, DNA, or nucleic acid. Right? Okay, let's move on to the definition of biomolecules first. So, see, carbohydrates, proteins, nucleic acid, lipids are all considered biomolecules. Okay, and let's move on to the first biomolecule, carbohydrate. What do we need to remember? They have a general formula. Okay, most of them have a general formula, CxH2OY. Okay, for example, glucose. Okay, but there are some like acetic acid, which also fit into this category, but it is not a carbohydrate. Similarly, rhamnose is a carbohydrate but does not fit in this definition. So it is not a concrete definition of carbohydrate. So they can ask you exceptions of this, and these two are the exceptions, acetic acid and rhamnose. You can answer. Next, what is the concrete definition? The bookish definition is carbohydrates may be defined as optically active polyhydroxy aldehydes and ketones, or the compounds which produce such units at hydrolysis. This is the bookish definition. No one is going to ask this to you, but still you should remember. Classification of carbohydrates, monosaccharides. Okay. If a carbohydrate cannot be hydrolyzed further to give simpler units, it is called a monosaccharide. So about 20 are known to us. Examples are glucose, fructose, ribose. Next, oligosaccharides. These yield 2 to 10 monosaccharide units. Okay. They are also classified further as disaccharide, trisaccharide, tetrasaccharide, etc., depending on the number of monosaccharide units that they yield. There is no concrete example of oligosaccharide, but examples of disaccharides are well known. For example, sucrose is a disaccharide which gives one glucose and one fructose, whereas maltose gives two molecules of only glucose. Polysaccharides. Polysaccharides are the carbs which yield a large number of monosaccharide units. So more than 10 typically we say, but usually polysaccharides yield hundreds to thousands monosaccharide units. For example, starch, cellulose, glycogen. Both three of them yield, see, starch yields glucose, cellulose yields glucose, glycogen also yields glucose. Okay. One thing which you need to remember about polysaccharides is they are not sweet in taste and they are not reducing either. So reducing and non-reducing concept. What is it? Suppose there are some monosaccharide units joined like this. Suppose four monosaccharide are there. I'll take some examples. Four monosaccharide is there and only one monosaccharide is there, and a large number of monosaccharides are there. Okay. This is the this is a monosaccharide, this is a oligosaccharide, and this is a polysaccharide. What a reducing sugar is, at one end of the monosaccharide, there will be COOH. Similarly, at one end of the oligosaccharide, there will be COOH. But in polysaccharide, you cannot find where the COOH is. It might be here, it might be here, it might be here. Okay. These three oligosaccharide units will not have COH because they are binding, they have bonds. The only free COH is found in the right side. This COOH, free COOH, is the reducing unit. So these two sugars are reducing sugars, polysaccharides are non-reducing. Got it? All those carbohydrates which reduce Fehling solution and tolerance reagent are reducing sugars. Monosaccharides are reducing sugars. Okay. Now, monosaccharides are further classified to the number of on the basis of the number of carbon atoms and on the basis of functional group. So either you will be having aldehyde as functional group or ketone as functional group, and the lowest amount of carbon will be 3. So a triose, which is an aldehyde. Triose is a monosaccharide having 3 carbons. Will be known as aldotriose or ketotriose. Similarly, you can see tetrose, pentose, hexose, and heptose. Aldo and keto ones. Okay. Glucose is an aldohexose. Fructose is a ketohexose. Ribose is a aldopentose. Ket Ribulose is a aldo, sorry, ketopentose. Okay. So these are some examples which you can remember, although you will be dealing with them in future also. Let's move on to preparation of glucose. The most important carbohydrate which we come across is usually glucose. How do you prepare it? Firstly, from sucrose, and you boil it. Okay. You boil sucrose with dilute HCl. You get glucose and fructose units. Okay. Equal amounts. From starch, this is the commercial method. Again, boiling it with dilute H2SO4. You will get glucose. Next, structure of glucose. See, we don't need to go through all this historical background. Just remember the structure of glucose. This is the second one is the structure of glucose. Okay. Third one, okay, this is not glucose. This is gluconic acid. So yeah, first one is your glucose. Okay. Gluconic acid is represented as second and saccharic acid as third. So what has happened in gluconic acid? The aldehyde in glucose is represented by C double bond OH. And in gluconic acid, the CH2OH is also represented by C double bond OH. Okay. So yeah, glucose has epimers. Okay. Which means C1, C2, C3, C4, C5, C6. This is all the glucose epimers. The epimers will be seen for the carbon number 2 and carbon number 4. So carbon number 2 epimer is known as mannose and carbon number 4 epimer is known as galactose. We'll come across them. So the D and L configuration, see, D-glyceraldehyde, capital D. Capital D is the capital D-glyceraldehyde means the second last carbon atom, which means the C5 is on the right side. So if I draw a glucose molecule, D and L, CHO, CH2OH. These four are important. The 2 to 5, C2 to C5 are important in determining the isomer. This is important, so you should listen. Yeah, only the third one will be inverted in glucose. This is, see, look at the second last carbon. The OH is on the right side, so this is D, glucose. Again, I draw the glucose molecule. This time I place the OH in the left side. According to that, I draw the glucose. The variation should only be at C3 again. Look at this. This is on the left side, so this is L glucose. Okay. This is what D and L, capital D and capital L mean. Now, what do these plus and minus things mean? So, yeah, plus is dextrorotatory, minus is levorotatory. So, yeah, levorotatory, dextrorotatory means if a plane polarized light is passed through them, the dextrorotatory compounds will rotate it to the right side, levorotatory ones will rotate it to the left side. Okay. This was all about, okay, yeah, plus is also, or dextrorotatory is also capital small t, and levorotatory is represented as small l also. Glucose is generally small d, and fructose is small l, levorotatory. So yeah, it is not necessary that all capital D ones will be dextrorotatory and all capital L ones will be levorotatory. They can be dextrorotatory also and levorotatory also. That depends on the compound which you have got. Okay, excuse me for the cold. Next is cyclic structure of glucose. Nothing. If the OH at C5 attacks the OH, attacks the carbon at C1, what will happen? That double bond with oxygen will get broken to a single bond. Hydrogen will attach itself to the broken oxygen and a link will be formed. So yeah, it looks something like this. Looks something like this. This is the link. This is C1. This is C5. Now there are two kinds of this whole glucose structure is called a pyranose structure. Okay. It has alpha or beta forms. In the alpha form, C1 and C2 are on the same side facing down. Beta form, C1 is up, C2 is down. C3 will be facing upwards in both of them. Structure of fructose, no need to remember. Let's move to disaccharides. Example is sucrose, glucose and fructose. Then sucrose is called invert sugar. Why? Because on hydrolysis, sucrose itself is dextrorotatory, but after hydrolysis, it gives dextrorotatory glucose and levorotatory fructose. But levorotation of fructose is more than dextrorotation of glucose. So mixture is levorotatory. That's why on hydrolysis, it gives inversion of the rotation and is called invert sugar. Then maltose. Maltose is composed of alpha D glucose and alpha D glucose. Lactose is composed of beta D galactose and beta D glucose. Polysaccharides, good example is starch. amylose and amylopectin. Amylose is water soluble and it's 15 to 20% of starch. Amylopectin is water insoluble, it is 85% of starch. Yeah, there is this branching link. It is between C1 and C6. Otherwise, all the links are between C1 and C4 in the link. Cellulose is a straight chain molecule. See, it's straight, it has no branching. It is composed of beta D glucose. Glycogen, again, similar to starch, but more highly branched. Okay, it also has branching at C1, C6, and normal chain length is like chain bond is C1, C4. Importance of carbohydrates. Nothing to explain in this. We come to proteins and amino acids. So, amino acids contain amino group, carboxyl group, and functional group. So, this is the basic representation of amino acid. There should be a carboxylic acid group, there should be amino group, and they are connected to a carbon which has a functional group called R. Now, R can be hydrogen, it is called glycine, methyl, it is called alanine, and so on. 20 amino acids are known to us in our human body. Classification of amino acids. First classification is non-essential amino acids and essential amino acids. So, non-essential amino acids can be synthesized in the body, but essential amino acids cannot be synthesized in the body and they must be obtained through diet. That is why they are essential. So, what are the essential ones? Histidine, tryptophan, phenylalanine, methionine, threonine, lysine, arginine, isoleucine, valine, leucine. Then structure of proteins. So primary structure, secondary structure, tertiary structure. Firstly, what is a bond between two amino acids? Which amino acids basically create proteins by a peptide bond. Okay, this is a peptide linkage between a C double bond OH and NH2 after removal of water. Now dipeptide, tripeptide, tetrapeptide, pentapeptide, hexapeptides are the ones which are formed after successively adding amino acids to each other. Roughly, proteins can be classified as two types basis of their shape. Fibrous proteins, they look like fibers. For example, keratin, myosin. Globular proteins, they look like spherical shape. Okay, they are usually soluble in water. Example are insulin and albumin. Then structure of proteins, there is a primary structure, which is the sequence of amino acid that makes the protein. Okay. This sequence of amino acid that is said to be the primary structure. So if you just see the sequence of amino acid, what comes after the other, that constitutes the primary structure, basic structure of protein. Now, if you fold that sequence, give it some kind of twist or something, it creates a secondary structure. Okay. It refers to the shape in which a long polypeptide chain can exist. They are found to exist in two shapes, two structures, alpha helix and beta pleated sheet. See, this is a alpha helix and this is a beta pleated sheet. These are two beta pleated sheets. Okay. What is the difference between alpha helix and beta pleated sheet is that see in alpha helix, the hydrogen bond, which I'm making by blue, between C double bond O and NH is between the COO and NH of the same chain. This is one polypeptide, right? So a hydrogen bond exists in the same chain. But here in beta pleated sheet, it is between two different beta chains. So this is the difference, and we call this difference intra and intermolecular hydrogen bond. Okay. Beta pleated sheet, intermolecular hydrogen bond, alpha helix, uh, hydrogen bond, normal, intra, okay, intramolecular. This was the secondary structure. Now tertiary structure. If you even further fold this alpha-helic beta-pleated sheet on themselves, it represents the overall folding of the polypeptide chain. It gives rise to tertiary structure. Fibrous and globular tertiary structure. The stabilizing forces for secondary and tertiary structures are hydrogen bonds, disulfides, van der Waal, electrostatic forces. Quaternary structure is like this is one polypeptide. There is one more polypeptide. This is these two are linked together somehow. So this is one polypeptide. This is one polypeptide. This has its own tertiary structure. This has its own tertiary structure. Together, both of them exist as a protein, and this will be the quaternary structure of the protein because there are two different polypeptide chains involved. So the spatial arrangement of these subunits or different polypeptide chains, if there are two or more polypeptide chains, they are referred to as subunits. Spatial arrangement of the subunits with respect to each other are quaternary structure. This is the diagrammic representation. This is primary, see, just one line, secondary, alpha helix. Tertiary is folding of alpha helix, and quaternary is two polypeptide chains. This is one polypeptide chain, and this is another polypeptide chain. Here, this is a better way. Just the amino acids. This is the alpha helix. This is the polypeptide folding. This is different subunits. Enzymes and mechanisms of enzyme action. Enzymes are proteins which are biocatalysts, and they are specific for a reaction. Then example is a maltase which breaks down maltose. Okay, and mechanisms of enzyme actions are they reduce the magnitude of activation energy. Enzymes are there are classes of enzymes. This example is an oxidoreductase. There are 7 classes of enzymes. Then there's a lot to elaborate on enzymes, but we'll not go there. We'll continue to vitamins. So they are very small, like they are obtained through diet usually and in very small amounts. Required in diet in the small amounts to perform specific biological functions and normal maintenance of optimum growth and health. There are A, B, C, D. Subgroups also is there, B1, B2, B6, B12, etc. etc. So there are two groups, fat soluble vitamins A, D, E, K. They are soluble in fat stored in liver and adipose tissue. Water soluble vitamins B and C group vitamins are water soluble. They are not stored because they are readily excreted in urine, cannot be stored except vitamin B12. B12 is stored in liver. So they should be supplied regularly in the diet. Okay. This is the two vitamins. You know the your B12 can readily be stored in liver because there is a inter intracellular protein which binds with your B12. The others don't have similar intracellular protein which can bind to them. Okay. Then let's see the diseases and sources. This is a table. I'm underlining some diseases, and you need to remember only those diseases. All right. For vitamin A source, for vitamin A source is carrots. Remember carrots, okay? And disease is zero ophthalmia if vitamin A is deficient. Vitamin B1 or thiamine sources green leafy vegetables and yeast. It causes beriberi. Okay. And vitamin B2 or riboflavin, main source is milk. Important source of B2 is milk. So yeah, B2 is associated with milk. It causes chiliosis. Okay. and burning sensation of skin. So skin manifestations for vitamin B2. P6 is pyridoxine. Remember these names also, okay? Sources: cereals, grams, egg, yeast. General sources: it leads to convulsions if absent or deficient. B12, meat is the major source. Fish, meat, egg, and all. For vegetarians, curd. It causes pernicious anemia. Okay. Vitamin C or ascorbic acid is mainly found in citrus fruit, causes scurvy. Vitamin D, you just need to expose yourself to sunlight, and deficiency causes rickets. Vitamin E, just remember vegetables oil, and the manifestation is muscular weakness. Vitamin K manifestation is increased clotting time. So decreased blood clotting will be the sources, green leafy vegetables. Let's move to the last classes. Last class of your biomolecule. Okay, lipids are there. Before lipids, we'll move to nucleic acids. So nucleic acids are responsible for transmission of inherent characters called heredity. There are two nucleic acids, DNA and RNA. Okay, they are composed of, they're polymers of nucleotides. So we'll remember learn what nucleotides are. So nucleotide is a pentose sugar, a phosphoric acid, and a nitrogen containing heterocyclic compound called base. Three components are there: an acid, a sugar, and a nitrogen base. So the sugar can either be beta D ribose or beta D 2 deoxyribose. 2 deoxyribose means, see, there is an OH here at second position. In deoxy, there will be just an H. Now, this DNA contains four bases: adenine, guanine, cytosine, thymine. RNA contains one more base, uracil. Uracil is instead of thymine. Thymine. Structures have been given. You can see adenine and guanine have big structures. Other three have small structures. So thymine only DNA, uracil only RNA. Structure of nucleic acids. On नहीं की जा. Coming to structures of nucleic acid. Firstly, you need to link the phosphoric acid molecule to the sugar. Okay. This is called a nucleoside. To form a nucleotide, you need to link it with the respective base. Okay. Sugar and phosphorus. So the sequence of linkage is phosphoric acid linked to sugar, sugar linked to base, forms a nucleotide. This is one nucleotide. Before that, the four bases, five bases. Adenine and guanine are big ones and they are called purines. These small ones are known as pyrimidines. So purines have two rings. Okay. Pyrimidines have one ring. Both of them contain nitrogen in the ring. Now the nucleic acid chain, how it is linked. The phosphoric acid of one nucleotide is linked to the sugar of the other nucleotide via a phosphodiester bond. This is how simplified version looks. Bases are not connected or linked in a chain. They are, there's a different. So bases project from the backbone of the chain, which is made by the sugar phosphate. Sugar phosphate makes the backbone. Bases project from the backbone. They also, the nucleic acids have a secondary structure of, okay, secondary structure For DNA, the secondary structure is double helix, which you can see here. There are two strands with the backbone outside and the bases projecting inside. The bases themselves are attracted to each other of the opposite strand through hydrogen bonds. G is attracted to C by three hydrogen bonds. A is attracted to T by two hydrogen bonds. Okay. The two strands are complementary to each other because the hydrogen bonds are formed between specific pair of bases. Adenine 2 with thymine, cytosine with guanine only. RNA, secondary structure, nothing which is very simple. It's a complex. It is a single stranded helix which sometimes fold backs on itself. There are four types of RNA: mRNA, messenger RNA, rRNA ribosomal, and tRNA transfer RNA. So DNA fingerprinting, you can read up on that. Biological functions, not very hormones. Coming to hormones, what are hormones? They can be any of these biomolecule. They can be proteins, nucleic acids, lipids, carbohydrates, polypeptides, anything. Usually they are lipids or protein. Okay. The main thing which stands out here is they are intercellular messengers. So a biological definition of hormone, if I write down, they are trace, like they are hormones are non-nutrient chemicals produced in trace amounts by body and act on a distinct organ or cell. So they are molecules that they're non-nutrient chemicals. Okay, non-nutrient means they are not used for nutrition. They are intercellular messengers. They are not nutritious. They are not food for the body. They are produced in trace amounts, very less amount. They act on in distant organs, so they are chemical messengers. So in terms of chemical nature, they are steroids. Examples is estrogen and androgens. They are polypeptides, insulin, endorphins. Otherwise, there are amino acid derivatives such as epinephrine and norepinephrine. These are the chemical classification for hormones. Now they have several functions of the body. They have given functions of a few hormones. See, insulin, blood glucose level maintenance. Okay. If insulin is impaired, insulin release, you will get diabetes. Then glucagon tends to increase the blood glucose, insulin tends to decrease. If there is defect in homeostasis between the two, like coordination between the insulin glucagon system is lost, if one of them is impaired or if both of them are impaired, then insulin, the glucose level in the blood will fluctuate. Epinephrine and norepinephrine mediate responses to external stimuli. Growth and sex hormones play a role in growth and development. Thyroxine. Thyroxine, abnormally low level will lead to hypothyroidism, which is characterized by letharginess and obesity. Increased level hyperthyroidism, low level of iodine may lead to hypothyroidism and goiter. These were the peptide hormones. Let's go to steroid hormones. Adrenal cortex and gonads produce these steroid hormones. For the adrenal cortex, the glucocorticoids control the carbohydrate metabolism. They control inflammatory reactions and stress. There are mineralocorticoids, they control excretion of water and salt by kidney. So if cortex does not functional property, then Addison's disease is there. If adrenal cortex is not functioning, hypoglycemia, weakness, stress, okay, usually it is fatal. Now hormones released by gonads, They are for the development of secondary sexual characteristics. Testosterone in males, estrogen in females. Testosterone develops the secondary male characteristics, deep voice, facial hair, physical constitution. Estradiol is the main female sex hormone. Okay. It controls menstrual cycle and secondary female characters. Progesterone is also there in females, preparing the uterus for implantation of the fertilized egg. So this was all about your biomolecules. They have not covered lipids, but okay. Anyways, lipids are also there. They are the fats. They're also found in your body. But it's complicated to categorize and explain lipids as they did for the other. So we need to remember only these three. And apart from these three, we need to remember vitamins and hormones. Okay, good. Let's move on to the JEE-Main previous year questions. First question says uracil is a base present in DNA. Percentage nitrogen in uracil is. So we need to calculate the percentage nitrogen. Let's first fulfill the valency of all the carbons here. Okay, only these many hydrogens are there. Now let's calculate 5 carbon, so 60, 2 oxygen, so 32, 2 nitrogen, 28, and 4 hydrogen, so 4. This comes out to be 124 is the molecular mass, and nitrogen is 28 by 124. So almost 22%. Okay. Total number of tripeptides possible by mixing of valine and proline. So valine and proline are amino acids and you have to form tripeptides. So let's see the possibilities. So one is valine, proline, proline. Okay. Then proline, valine, valine. Okay. Okay. Let's take a different approach. One valine and two prolines. So valine, proline, 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 valine, proline. Okay. These are the two tripeptides which can form. Then one proline and two valine, proline, valine, 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 proline, valine. So yeah, 1, 2, 3, 4. This is the total number of tripeptides. So they have not mentioned any condition. We can think further also. We can think that only proline are present and only valine are present. This is the fifth, so this is the sixth. So usually, if they have not mentioned anything, assume that both should be present in the tripeptide. So answer will be 4. If they're mentioned, then yeah, you can also answer 6. Okay, so this is a bit difficult, like bit question which puts us on dilemma. Let's check what solution is. So yeah, see, they have not only assumed that they have not only assumed that there are polypeptides with just proline and valine. They have also assumed one more thing. The other thing that they have assumed is the orientation of the polypeptide. They have given ends to it. This is left end, this is right end. So they have differentiated the ends also. What I'm trying to say is, see, what we did is we just assumed that we gave the simple assumption that V P P is equal to P P V, because it's just the mirror image. But they have said that this is also different. So we can write for one valine and two proline, P P, V also. And in this, we can write V, V, P also. Then 3 proline and 3 valine. So now it comes out to be 8. So I think you should, if you're getting a question like this, don't try to attempt it if you are not 100% sure. Skip it because this is not a clear question. Okay. Attempting may lose marks even if you are correct. They have not given it like good information here. Next, match items of row 1 with row 2. So row 1 gives you this molecules. Let us try to decipher the molecules. This is a furanose ring. This is a pyranose ring. So yeah, the PQR glucose, R is fructose, right? So in glucose, what did we learn about alpha and beta? In alpha, both OH will be down in C1 and 2. So you see 1, 2, both of them are down. So this is alpha D glucose. This one is beta D glucose. Similarly, in fructose, this is beta D fructose, alpha D fructose. Okay, see alpha D glucopyranose. See P is alpha D glucopyranose. So P will be 3, Q will be 4, R will be beta fructose. So R will be 2, S will be 1. So third is your correct option. Now number of cyclic tripeptides formed with two amino acids A and B. So A, B, A. This is like with 2A. 2 A's, 1 B. Tripeptides. Okay. This is one for like possible formation. There is no other possible formation. Like 2B, 1A, A, B, B. Again, if we assume ki 3A or 3B are present, then the total number should be 4. But let's see what they have assumed. Question 4. So they have, yes, they have assumed that these two also exist. So you give the answer at 4. So usually if you get these kinds of question, answer all possible ones. Don't give consideration from yourself. Don't restrict yourself. However you can form, you just form it. Okay, so answer is 4. This is 1, this is 2, and this is 3, this is 4. Following tetrapeptide can be represented as. So this is an amino acid chain. We have to recognize the individual amino acids. Okay. See, this is one amino acid. Okay. This is the second amino acid. This is the third amino acid. This is the fourth amino acid. Look at the R groups in all of them. The R group for this one is this. Here the R group is this. And here the R group is this. So naming them 1, 2, 3, 4. As you can see, 1 is equal to 4. Both of them have CH2 phenyl. 1 is equal to 4. Oh, I'm really sorry. It's not like that. This is phenol. 1 is not 4. So 1 and 4, 1 and 4 are aromatic amino acids. Tryptophan, threonine, phenylalanine. Okay. So phenylalanine, see what alanine is. Alanine is the R group in alanine is CH3. This is alanine. So phenylalanine is alanine with a phenyl group. So first one is phenylalanine, right? Then look at the second one. Second one is the CH2OH. So it is an acidic amino acid. So either it can be glutamic acid or aspartic acid. I think it is aspartic acid only. So yeah, this is aspartic acid. We need to remember the code names also. First one could be threonine, and the third one could be your, I think, lysine. Let's check out. Number 6. See, first one is phenylalanine. It is leucine, not lysine. It is leucine. Third one is aspartic acid. Fourth one is tyrosine. Oh, that is not threonine. It is tyrosine. So we have deciphered the names. This is leucine. This is tyrosine. Rest are the other two are okay. So tyrosine, phenylalanine, leucine, and aspartic acid. So yeah, this is the correct answer. F for phenylalanine, L for leucine, D for aspartic acid, Y for tyrosine. See, these all are given in NCRT, so you should read NCRT line by line. Although I did not, I skipped this part, but you should not skip anything. I was just doing a brief revision. Next question is, ketos give Selivanov test faster than aldose. Yeah, this is true. Ketos undergo beta elimination followed by formation of furfural. See, both are true, but it is not the correct explanation. Then short peptide on complete hydrolysis produces 3 moles of glycine, leucine 2, and valine 2. The number of peptide linkages in it are, how many amino acids are there? 3 to 2, so 7 amino acids. So peptide linkages will be 6 peptide linkage. Protein X molecular weight is given, gives amino acid. One of this amino acid is, so you have to just find out the amino acid. This is not an amino acid because on the alpha carbon, COH and NH2 are not together. This is not an amino acid. Alpha carbon पे NH2 नहीं लगा है. This is again not an amino acid. Alpha carbon पे NH2 नहीं है. This is the correct answer because on the alpha carbon there is both C double bond OH both and NH2. R group can be anything. So yeah, this is an amino acid. Next question is, a compound C5H10O5 gives tetraacetate with ACO acetate, and oxidation of A with bromine water gives an acid C5H10. Reduction of A with HI gives isopentane. So HI can be. Isopentane is being given, so there is no isopentane looks something like this. So it is not a straight chain molecule. So yeah, all of them except this. This cannot give an isopentane structure because it is a straight chain structure. See, all other have an isopentane kind of backbone. Okay. All of them have an isopentane kind of backbone. Now, it gives a tetraacetate with on acetylation. So tetraacetate means there are 4 OH groups. This cannot be there only. Oh yeah, there are 4 OH groups here. There are four OH groups here, there are four OH groups here, and there are four OH groups here also. So these three can be there. Bromine water, it gives an acid. It gives an acid C5H10 6. So if there is an acid, what is the explanation here? Ninth question. Four OH linkages are there. Isopentane, so they have given just one. I think this is not a correct question because all three of them can give all these compounds. Hence, we have to go with the most linear answer. Consider that these two are ketoses and first one is aldose. So two ketoses might be the wrong answer. And if there is one aldose, we just give aldose as the correct answer. So this is how you do in some situation. You find out the least incorrect answer. Correct representation of a six-membered pyranose ring in the following sugar. So yeah, C1, C2. See, C1 and C2 should be. Sorry, this is 1, this is 2, this is 3. So C3 and C2 should be on the same side. This can't be the thing. Yeah, this can be one configuration. This is the only answer. Yeah, first one is the, sorry, second one. Second one is the answer. Then match these lists. Smallest test is for carbohydrate. Biurate test is for peptides. Carbylamine test, primary amine. Schiff's test for aldehyde. So smallest test. This is the answer. Then assertion and reason. Alpha halocarboxylic acid on reaction with dilute HNH3 gives alpha amino carboxylic acid. Amino acid expression Zitoran formula. So yeah, both are correct, but R is not the explanation. Right. So yeah, guys, we are done with the exercise also. So yeah, we have completed biomolecules. Try to read it from the NCERT. Don't miss any table, any graph, anything when you are doing your reading. That will help you solve most of the questions in your JEE mains. Okay, we are done for today. All the best, guys, for your JEE mains and have a great day. Goodbye.